We want to practice writing neutralization reaction. And neutralization reactions are those between a base, and you can also hear it as alkaline, but let's write both of them, a base or an alkaline, reacting with an acid. And when those two react together, they will form a salt plus water. Sometimes you have also carbon dioxide, but just in some cases, so let's skip that for now. So bases, really important that we know which bases, what are bases and what are alkalines. So we need to be confident in recognizing these compounds. And remember that those are compounds that have a pH above 7. Acids are those compounds that have a pH below 7. Salts and water, well, it's neutral because it's a neutralization reaction. A base, it's a compound that has a pH above 7, but in the solid form because it's not soluble in water. While an alkaline, it's a compound that reacts with an acid that has a pH above 7, but it's soluble in water. So we would write it in aqueous solution if we are reacting a solution. Of course, it can also be in the solid state. While an acid, it's always aqueous because that's kind of the definition of an acid, that it releases. The definition of an acid is actually it's a proton donor in aqueous solution, and the proton is an H+ ion. So that's why all the acids that we will see, they will have this H+ ion. Okay, and then we will get to the salt. Let's look at what are bases and what are alkalines. Examples to know. Bases are metal oxides, metal hydroxide, metal carbonates. To write the formula is just the metal plus oxygen. It's bonded with oxygen. Let's write some example. Potassium oxide, magnesium oxide, aluminium oxide. Just remember how to write the formula of these compounds because we need to remember that oxygen has a charge of 2-. Hydroxide and carbonate are those polyatomic ions that we do need to remember the formula of. Hydroxide is OH-. Carbonate, it's a CO3 2-. So we need to learn how to write this formula. Metal hydroxide would be KOH. Magnesium hydroxide would be with the bracket, and so on. Metal carbonate could be, again, considering the charge, sodium carbonate, calcium carbonate, all of those are alkaline or bases, okay, depending on their solubility. Acids, common ones to know. Hydrochloric acid, sulfuric acid, nitric acid, phosphoric acid. So notice that all of these polyatomic ions, they form acidic solutions. And an organic one, CH3COH, ethanoic acid. All of those are acid because, look, they have this H+ that they can give away. Salt. A salt, well, it's neutral, first of all, but it's an ionic compound that is made from a base and an acid reacting together. The most important thing to know is that the metal of that salt comes from the base or the alkaline, while the non-metal always comes from the acid. So, for example, let's use some colors here. Let's say that we have a reaction between potassium hydroxide and hydrochloric acid. The formula of the salt would be the metal from the alkaline or the base, which is potassium. We need to recognize that by looking at the periodic table. And well, we know that it's a metal. So that's our metal. And what's the non-metal? The non-metal come from the acid, and that's of course not hydrogen, because hydrogen is what's involved in the reactions. So it will be the chlorine. Okay. Let's do another example. Let's say that we have the reaction between magnesium hydroxide and sulfuric acid. Yeah, the metal would be the magnesium, and the non-metal would be the whole negative ion of the acid, so it would be sulfate. The only thing is that we would need to consider the charges. Okay. One other last thing to add is that when we have a carbonate, in addition to water, the neutralization product is also carbon dioxide, a gas. And to finish this off, salt can be aqueous if it's soluble, or will be a solid if it's insoluble. Most of the salts are soluble. So if you're unsure, better to write aqueous. And water would be written as a liquid. So how to learn this neutralization reaction? My suggestion is to have a list of alkali or bases, a list of common acids, maybe with their name, and practice their combination. So you can just, I would suggest to do something like that. Okay, let's write the reaction between sodium oxide plus, you can choose an acid from your list, let's say nitric acid. Let's work out the salt, and then we know that it's going to be water, because there is no carbonate, so it's just water, the neutralization product. So the key, the very useful exercise here would be word equation, work out the name of the salt, and then the symbol equation by writing formula, so sodium oxide, and maybe their physical state too, nitric acid. Yeah, from this list of acid and bases that you can make and then refer to when you're practicing it. And then let's work out the formula of the salt, and well, we know water is formed, and then you can also practice balancing. So just
water is always formed.
Water is always formed, yes, because it's a neutralization reaction. The only one that doesn't have water, it's a base very specific, which is ammonia, which is NH3. When ammonia reacts with, for example, HCl, it would form just the salt, so it would be NH4Cl. Okay, this would be, in fact, the water is not present, but you would know it because, well, there is no oxygen here, so where would the water be formed? So this is the exercise that I suggest to practice, writing the word equation, the symbol equation, balancing, yeah, by having a list of common. And how to make this list? Well, why don't you scroll through your book and look at the ones that are mentioned, the ones that are shown in the equation, okay? And this would be all the ones that you would come across in a test or in an exam, okay?